Welcome back, students. Now we will be exploring the second type of evidence. Now we will remember some geometric rules, properties, and theorems that we'll be using to solve the exercises of chapter 11 and see what evidence do each present. We will be focusing on the following: isosceles triangle properties, common side of two triangles, perpendicular lines effect, perpendicular bisector theorem, converse of the perpendicular bisector theorem, rectangle properties, corresponding elements of two congruent triangles, angle bisector properties, complementary, supplementary, and vertically opposite angles properties. Part 1, isosceles triangle properties. Let's see this animation. An isosceles triangle has two equal sides called legs, and we have here this common vertex of these two equal legs called the main vertex of the isosceles triangle. The side opposite to the main vertex is called the base of this isosceles triangle, and the two base angles are equal. So let's remember, legs of an isosceles triangle are equal, and the base angles of an isosceles triangle are equal. Exercise 1. In this adjacent figure, ABC is an isosceles triangle of vertex B. Write all possible evidence that we can claim and state the reason. In this exercise, we don't have any straightforward evidence written in the text or codes written or placed on the figure. We only have this important information, the fact that ABC is an isosceles triangle. So the evidence that we can claim are related to the properties of an isosceles triangle. We can claim the fact that BA equals BC because they represent the legs of this triangle, and angle BAC equals angle BCA. These are the two base angles in this isosceles triangle, and they are equal. Solution: BA equals BC, but since it's not a straightforward evidence, it's deduced from the properties of the isosceles triangle. So the reason is here, it's not given because they represent the legs of the isosceles triangle ABC. We need to mention the triangle and mention its main vertex of vertex B. Also, BAC equals BCA. Also, it's not a straightforward evidence. We cannot write a given as the reason because these two angles, they represent base angles of isosceles triangle ABC of vertex B. Also, we can name these two angles BAD and BCD, or BAD equals BCD, base angles of isosceles triangle ABC of vertex B, because the 3 points A, D, and C, because they are collinear points. So we can name these two angles in a different way. So now we notice that we can't claim anything related to the line BD. Here BD, it looks like it's perpendicular to AC, but we don't have the code of the right angle here. Nothing is mentioned about line BD, so we cannot claim the fact that BDC or BDA are right angles, or that BD is the height relative to AC. We cannot claim that D is the midpoint of AC. We cannot claim that BD is the median relative to AC, nor the perpendicular bisector of AC, because no information are mentioned about this line. So be careful. We can't claim an evidence that is not mentioned or that we don't know anything about. Exercise 2, refer to the figure and show that ABC is an isosceles triangle. So in this figure, we don't know the fact that the triangle ABC is isosceles yet. but we know, looking at the codes, that BA equals BC. And to prove that a triangle is isosceles, either we prove that it has two equal sides or that it has two equal angles. Here, we know that BA equals BC, so we can easily prove that this triangle is isosceles. So BA equals BC, and the reason is given. Result, ABC is an isosceles triangle, and we need to mention the main vertex of vertex B, since it has two equal sides, BA equals BC. Exercise 3, refer to the figure, show that ABC is an isosceles triangle. Also, in this figure, we cannot claim yet that ABC is an isosceles triangle. We need to prove it. So here, looking at these two codes, we can claim that BAC equals BCA. Prove BAC equals BCA. The reason is given. Then the result is ABC is an isosceles triangle of vertex B, since it has two equal angles, BAC equals BCA. So to prove that a triangle is isosceles, we have two methods. Either we prove that it has two equal sides or that it has two equal angles. Part 2, common side of two triangles. Two triangles that appear glued together share or have a common side. Example, refer to the figure. Write all possible evidence that we can claim and state the reason. We notice that triangles ACB and ACD are glued together at side AC. ACB and ACD. It means AC is a side of ACB and ACD at the same time. We call AC a common side of triangles ACB and ACD. Easy way to see if two triangles have a common side. First, we write the name of the two triangles. We check if two letters are repeated in their name. We notice that letter A is repeated. This is the first letter. And letter C also is repeated. In this example, letters A and C are repeated. The order doesn't matter. They don't have to be consecutive after each other. So it means that the side AC is a common side. Solution. AC, the side AC of the triangle ACB, is equal to the side AC of the triangle ACD. So this, and the reason is common side. So this is the only evidence that we can claim. Part 3, perpendicular lines effect. Two perpendicular lines form a right angle of 90 degrees. Example, in this adjacent figure, ACD is a triangle. It's a scaling triangle. We cannot claim that it's isosceles. The perpendicular at A to AC cuts CD at E. When we draw the perpendicular to AC, we keep on extending it and also extending the line CD until they meet at E. The perpendicular at A to AD cuts CD at B. Also, when we draw the perpendicular to AD, we keep on extending it and the line DC until they meet at point B. Write all possible evidence that we can claim and state the reason. So here we cannot claim anything about the sides. No information are mentioned. We can only claim that the angle CAE equals angle DAE equals 90 degrees because of the perpendicular. Solution, DAB equals CAE equals 90 degrees, and the reason here it's not given, it's because of the perpendicular. We write perpendicular effect. Now part 4, perpendicular bisector theorem. We will be covering the theorem in our next video. This is the end of part 2, and see you in part 3.